Top 30 Data Science Full Course Interview Questions and Answers. This guide provides essential data science interview questions with detailed answers. It covers core concepts, tools, techniques, and real-world applications to help you prepare confidently and effectively. 1. What is data science? Data science is a multidisciplinary field that combines statistical analysis, machine learning, programming, and domain knowledge to extract meaningful insights from structured and unstructured data. It enables organizations to make data-driven decisions, uncover hidden patterns, and optimize operations. A typical workflow includes data collection, cleaning, exploration, modeling, evaluation, and deployment. Data scientists use tools like Python, R, SQL, and cloud platforms. The main goal is to transform raw data into actionable intelligence that improves business outcomes, operational efficiency, and strategic planning. 2. What are the key responsibilities of a data scientist? A data scientist is responsible for gathering, cleaning, analyzing, and interpreting large datasets to derive actionable insights. They build predictive models, evaluate performance, and communicate findings to stakeholders through visualizations and reports. They collaborate with cross-functional teams, including engineers and business leaders, to implement data-driven solutions. Additionally, they monitor deployed models, ensure data quality, and automate processes where possible. They must understand business problems, choose suitable algorithms, manage data pipelines, and maintain documentation. Strong communication, programming, and statistical skills are essential for success. 3. What is the difference between supervised and unsupervised learning? Supervised learning involves training models using labeled data where the target outcome is known, enabling the algorithm to learn a mapping between input and output. Common tasks include classification and regression. Unsupervised learning, however, deals with labeled data and focuses on discovering patterns or structures such as clusters or associations. Examples include clustering, dimensionality reduction, and anomaly detection. While supervised learning predicts outcomes, unsupervised learning finds hidden relationships. Both approaches are essential in data science and are chosen based on problem requirements and data availability. 4. What is overfitting in machine learning? Overfitting happens when a model learns noise or random fluctuations in the training data, resulting in poor performance on new, unseen data. It often occurs when models are too complex relative to the dataset. Symptoms include high accuracy on training data but low accuracy on testing data. Techniques to reduce overfitting include cross-validation, regularization, pruning, simplifying the model, and using more training data. Proper feature selection and dropout, for neural networks, also help. Balancing model complexity and generalization is essential to avoid overfitting. 5. What is feature engineering? Feature engineering involves transforming raw data into meaningful features that improve model accuracy and performance. It includes tasks such as handling missing values, encoding categorical variables, scaling numerical features, and creating new derived features based on domain knowledge. Good feature engineering can significantly impact model success by making patterns more detectable to algorithms. Techniques like one-hot encoding, binning, normalization, and polynomial features are commonly used. The goal is to represent data in the most informative way for machine learning models. 6. What is the role of statistics in data science? Statistics plays a foundational role in data science by enabling data analysis, inference, and decision-making. It helps professionals understand data distribution, variability, and relationships among variables. Concepts like probability, hypothesis testing, confidence intervals, and regression analysis allow data scientists to validate assumptions and draw meaningful conclusions. Statistical methods are essential for feature selection, model evaluation, and experimental design. Without statistics, it would be difficult to interpret results, assess model reliability, and ensure predictions are trustworthy. It is a core skill in the data science workflow. 7. What is a confusion matrix? A confusion matrix is a performance evaluation tool for classification models. It shows the count of true positives, true negatives, false positives, and false negatives. These metrics help calculate accuracy, precision, recall, and F1 score. By visualizing how predictions compare to actual outcomes, the confusion matrix helps identify model weaknesses. For example, it can reveal class imbalance issues or biases. It is widely used in binary and multi-class classification to assess how well the model differentiates between categories. Understanding it is essential for improving predictive accuracy. 8. What is dimensionality reduction? Dimensionality reduction is the process of reducing the number of input features while retaining essential information. It helps improve model performance, speed up computation, and reduce noise. Techniques include principal component analysis, TSNE, autoencoders, and feature selection methods. High-dimensional data often leads to overfitting and increased complexity, making dimensionality reduction important for efficient modeling. By simplifying data representation, it enhances interpretability and enables visualization of complex datasets. It is useful in domains like genomics, text analytics, and image processing. 9. What is a neural network? A neural network is a computational model inspired by the human brain. It consists of interconnected neurons organized in layers that process data by applying weighted transformations. Neural networks can learn complex nonlinear relationships and are widely used in deep learning applications such as computer vision, natural language processing, and speech recognition. Training involves adjusting weights through backpropagation and optimization algorithms like gradient descent. Networks vary in complexity, from simple feedforward designs to advanced architectures such as CNNs, RNNs, and transformers. 10. What is the bias-variance trade-off? The bias-variance trade-off refers to balancing underfitting and overfitting in machine learning models. Bias represents errors from overly simplistic models that fail to capture data patterns, while variance reflects errors from overly complex models that memorize data noise. A good model achieves low bias and low variance by properly tuning complexity. Techniques like cross-validation, regularization, and ensemble learning help manage this trade-off. Understanding it is crucial for selecting the right algorithm and achieving better generalization on unseen data. 11. What is exploratory data analysis? Exploratory data analysis is the process of examining datasets to understand their structure, patterns, anomalies, and relationships using statistical summaries and visualizations. It helps uncover insights, validate assumptions, and guide feature engineering and modeling decisions. Tools commonly used include histograms, box plots, scatter plots, and correlation matrices. EDA ensures data quality by identifying missing values, outliers, and inconsistencies. It is a critical step before building any model, as it provides context and direction for the rest of the analysis workflow. 12. What is the difference between classification and regression? Classification predicts categorical outcomes, such as determining whether an email is spam or not. Regression predicts continuous numerical values, such as estimating house prices. Both belong to supervised learning but differ in output type. Classification uses metrics like accuracy, precision, and recall, while regression uses metrics such as mean-squared error and R-squared. Algorithms for classification include logistic regression, decision trees, and support vector machines. Regression models include linear regression and random forest regression. The choice depends on the problem and data characteristics. 13. What is cross-validation? Cross-validation is a model evaluation technique used to assess how well a model generalizes to unseen data. It involves splitting data into multiple subsets, training on some subsets, and validating on the remaining ones. The most common method is k-fold cross-validation, where data is divided into k-folds. It reduces model bias, prevents overfitting, and ensures reliable performance estimates. Cross-validation is especially useful when datasets are small. It helps compare algorithms, tune hyperparameters, and improve model robustness. 14. What is a decision tree? A decision tree is a supervised machine learning algorithm that uses a tree-like structure to make decisions based on feature values. Each internal node represents a decision rule, and each leaf node represents an outcome. Decision trees are easy to interpret, handle both numerical and categorical data, and require minimal preprocessing. They work well for classification and regression but can overfit without pruning. Ensemble methods like random forests and gradient boosting improve their performance by combining multiple trees to enhance accuracy and stability. 15. What is a random forest? A random forest is an ensemble learning algorithm that builds multiple decision trees and combines their predictions through voting or averaging. It improves accuracy, reduces overfitting, and handles high-dimensional data effectively. Each tree is trained on a random subset of data and features, introducing diversity that enhances performance. Random forests are used for classification, regression, and feature importance analysis. They work well on complex datasets and provide robust results even with noisy data. They are widely used due to their reliability and simplicity. 16. What is gradient descent? Gradient descent is an optimization algorithm used to minimize a cost function by iteratively updating model parameters in the direction of the steepest descent. It calculates gradients of the loss with respect to parameters and adjusts them to reduce error. Variants like stochastic gradient descent and mini-batch gradient descent improve efficiency when dealing with large datasets. Gradient descent is essential in training neural networks and other machine learning models. Proper learning rate selection is crucial to ensure convergence and prevent divergence or slow learning. 17. What is regularization in machine learning? Regularization is a technique used to prevent overfitting by adding a penalty to the model's loss function. It discourages overly large coefficients that can capture noise instead of meaningful patterns. Common methods include L1 regularization, which promotes sparsity, and L2 regularization, which shrinks coefficients. Regularization improves model generalization and stability. It is especially useful in linear models and neural networks. Choosing the right regularization strength helps balance complexity and performance. Regularization is a key strategy for developing robust and reliable models. 18. What is natural language processing? Natural language processing is a field of artificial intelligence that focuses on enabling machines to understand, interpret, and generate human language. It involves techniques like tokenization, part-of-speech tagging, sentiment analysis, and named entity recognition. NLP powers applications such as chatbots, translation systems, search engines, and voice assistants. Advanced models like transformers have significantly improved performance in text understanding tasks. NLP combines linguistics, machine learning, and deep learning to analyze communication patterns and derive meaningful insights from text-based data. 19. What is deep learning? Deep learning is a subfield of machine learning that uses neural networks with many layers to learn complex data representations. It is highly effective in tasks like image classification, natural language processing, and speech recognition. Deep learning models automatically learn features without manual engineering, making them powerful for unstructured data. Training requires large datasets and high computational power. Techniques like convolutional networks, recurrent networks, and transformers are examples of deep learning architectures. Deep learning has revolutionized many industries through superior accuracy and advanced automation capabilities. 20. What is big data? Big data refers to extremely large and complex datasets that cannot be processed using traditional methods. It is characterized by volume, velocity, and variety. Big data technologies like Hadoop, Spark, and distributed storage systems enable efficient processing and analysis. Organizations use big data to uncover trends, improve decision-making, optimize operations, and personalize services. Big data analytics involves cleaning, transforming, visualizing, and modeling massive datasets. It is widely used in finance, healthcare, marketing, and social media, where huge amounts of data are generated every second. 21. What is a data pipeline? A data pipeline is a series of processes that automate the movement, transformation, and storage of data from source systems to destinations such as databases or analytics platforms. It ensures reliable, consistent, and scalable data flow for modeling and reporting. Components include data ingestion, cleaning, validation, transformation, and loading. Pipelines may run in batch or real-time depending on business needs. Tools such as Apache Airflow, Kafka, and AWS Glue support pipeline orchestration. A well-designed pipeline reduces manual effort and ensures high-quality, ready-to-use data. 22. What is a hypothesis test? A hypothesis test is a statistical method used to evaluate assumptions about a population based on sample data. It determines whether observed differences are statistically significant or due to random chance. The process involves defining null and alternative hypotheses, selecting a significance level, and calculating test statistics. Widely used tests include t-tests, chi-square tests, and ANO versus A. Hypothesis testing is essential for validating results, comparing groups, and supporting data-driven decisions. Understanding p-values and confidence intervals helps interpret findings more accurately. 23. What is SQL and why is it important in data science? SQL is a programming language used to manage and query relational databases. It is essential in data science because it enables efficient data extraction, filtering, aggregation, and manipulation. SQL helps data scientists access large datasets stored in enterprise systems. It supports joins, subqueries, and window functions for complex analysis. Proficiency in SQL ensures smooth collaboration with data engineers and analysts. It is widely used in business intelligence, reporting, and building machine learning pipelines. SQL skills are fundamental for working with structured data effectively. 24. What is data cleaning? Data cleaning involves identifying and correcting errors, inconsistencies, and missing values in datasets to improve accuracy and reliability. It includes handling duplicates, fixing formatting issues, and validating data types. Clean data ensures meaningful analysis and enhances model performance. Techniques involve imputation, normalization, encoding, and outlier treatment. Data cleaning is often the most time-consuming step in data science but is crucial for trustworthy results. Without proper cleaning, models may produce misleading predictions and insights. It is a foundational step in the data lifecycle. 25. What is a ROC curve? A ROC curve is a graphical representation of a classification model's performance across different thresholds. It plots the true positive rate against the false positive rate, highlighting the trade-off between sensitivity and specificity. The area under the ROC curve measures overall model quality. Higher values indicate better performance. ROC curves help compare models, select optimal thresholds, and evaluate imbalance effects. They are widely used in medical diagnostics, fraud detection, and risk assessment. The curve provides clear insights into model behavior. 26. What is reinforcement learning? Reinforcement learning is a machine learning approach where an agent learns to make decisions by interacting with an environment and receiving rewards or penalties. It focuses on maximizing cumulative rewards through trial and error. Key components include states, actions, policies, and reward signals. Common algorithms include Q-learning and deep reinforcement learning. It is used in robotics, gaming, recommendation systems, and automation tasks. Reinforcement learning excels in dynamic scenarios requiring continuous adaptation. It mimics human learning patterns and supports complex decision-making problems. 27. What is the purpose of feature selection? Feature selection aims to reduce the number of input variables while retaining those most relevant to model performance. It enhances accuracy, reduces overfitting, and speeds up training. Methods include filter techniques like correlation analysis, wrapper techniques like recursive feature elimination, and embedded methods like LASSO. By simplifying the dataset, feature selection improves interpretability and reduces computational cost. It is especially important when dealing with high-dimensional data where irrelevant features can harm model accuracy. 28. What is cloud computing in data science? Cloud computing provides scalable resources for storing, processing, and analyzing data without relying on local infrastructure. Platforms like AWS, Azure, and Google Cloud offer tools for data storage, machine learning, and pipeline automation. Cloud computing allows teams to collaborate, deploy models, and manage large workloads efficiently. It supports real-time processing, distributed computing, and cost-effective scaling. Cloud technologies are essential for handling big data, deploying production models, and enabling flexible experimentation. They play a major role in modern data science operations. 29. What is data visualization? Data visualization is the process of presenting data insights through charts, graphs, and interactive dashboards. It simplifies complex information, making patterns and trends easier to understand. Tools like Tableau, Power BI, and Matplotlib help create meaningful visuals. Visualization supports decision-making by enabling stakeholders to interpret results quickly. It is used in exploratory data analysis, reporting, and model evaluation. Effective visualizations highlight relationships, reveal anomalies, and communicate findings clearly. Good design principles enhance clarity and engagement. 30. What is model deployment? Model deployment involves integrating a trained machine learning model into a production environment where it can generate real-time predictions. Deployment may use APIs, cloud platforms, or embedded systems. It includes monitoring performance, handling model drift, and managing scalability. Deployment ensures data science models provide value by supporting actual business operations. Tools like Docker, Kubernetes, AWS SageMaker, and Flask enable deployment workflows. Proper deployment includes validation, documentation, and continuous integration practices to maintain reliability and performance over time. These questions provide a strong foundation for mastering data science interviews. Reviewing them will enhance your confidence, skills, and readiness for real-world data-driven challenges and opportunities.